everyone, welcome back to Chem Corner. And today we are going in the same breakdown of AP FRQ questions 2025. And today we are tackling question number 3. Okay, let's directly dive into the question. Here we go. So the third question is also long FRQ type. Let's get started. They were given P4 molecules, see its tetrahedral structure, and you need to complete this low structure. That's the first question. Okay, so here already they were given like three single bonds are there. Each bond is single bond, and you know phosphorus is nitrogen family, so 5 valence electron is there. So definitely two more lone pairs are there. Like one lone pair is there. Okay, two electrons are there. So each phosphorus you can draw one lone pair of electron. That's a complete structure. That's all. The B part is about a reaction. P4 reacting with the O2 gives P4O10, and you have to comment about their entropy. So they were already given it is negative, but you have to comment about it. Yes, definitely it should be negative, isn't it? Because the reactant, see, it is a solid plus gas mixture. Solid gas system is turning to solid again. So entropy is decreased. The what disorderness is decreasing because it's turning from a gas to solid. So definitely the entropy is decreased. That's why delta S is nothing but final minus initial. So final means product entropy, product disorderness minus initial disorderness. So definitely it will be a negative value because initial state how more chaotic, right? That's all. Then the second next part is enthalpy change for this reaction is also negative. Then the student is claiming like the driven force, the favorability of the reaction is not entropy, it is enthalpy. Okay, are you agreeing with that one? We can agree that one, right? The claim is correct. And you know the spontaneity is determined by two factors. One is delta H and the second factor is delta S, and the combined effect is what we call delta G. Okay, so what do you mean by favorability for delta H? You know, exothermic reactions are favorable. Exothermic reaction means delta H should be negative. That is the condition for favorable. Delta S, entropy have to be increased. So favorability means increase in entropy is favorable. Okay, so in this case we already found delta S is negative, but delta H is negative. So this is disfavorable, but this is favorable. So the only condition which is favorable for the spontaneous reaction is in this case delta H negative. Okay. The next part of the question is a calorimetric question. They were given a reaction P4O10 solid plus 6H2O liquid, and they were formed H3PO4. Okay, phosphoric acid. Then calorimetric data is given. Okay, you need to find out the amount of Q released during the experiment. So how do you find this calorimetric thing? First you have to find out the Q water. Okay, Q water is our surrounding thing. That is the first step. Find the Q water. So what's the equation? MC delta T. So be careful. M is not the water alone. M means combined mass. If the substance is dissolved, then the combined mass have to take place. Have to taken. Okay. So 100 plus 0.100 addition. So signet figure. When you think about signet figure rule, decimal place, lowest decimal number. That much of number should be in the uh, answer, right? So here lowest decimal point means 1 decimal point. So 100.1 grams of mass is there. And the specific capacity of water is 4.184. Okay, 18 only given. And delta T is final minus initial. So 22.38 minus 22. So it's just 0.38, correct? 0.38. So see again, decimal point. So 2 decimal point is there, right? So 0.38 is the thing. Okay, so what is the answer? What I got is 160 joule. Again, what we need? Kilojoule. This is 160 joule only. So kilojoule means 0.16 joule. Okay, how many signet figure? I need two signet figure, right? 0.38 contain only two signet figures. So just 0.16 kilojoule. And you can plug a negative sign because it's a release energy. Because Q water, be very careful, Q water is positive. So what about Q system? Q system means it's negative because water gained some energy because of system lost some energy. Water is the surrounding in this case. Okay, so Q system is negative, 0.16 kilojoules of energy. This is the released amount, so it should be negative. Okay. Then the next part, delta H reaction. So what is the difference between Q and delta H? Most of the students have doubt this thing. Del Q and delta H. Q means, so for that particular reaction, how much heat energy is involved. Delta H means the whole reaction. See in your top, this is a reaction. This is the reaction. For this reaction, we always write the thermochemical reaction like delta H value. So what should be the delta H value? I have to write there. Okay, that is the question. So Q is for this reaction. For this reaction means, see, negative 0.16 kilojoules of energy is only about 0.100 system. 0.100 means, see the P4O10, that's a P4O10 grams, correct? So what is the question? For 1 mole, because the balanced chemical reaction we seen, it's 1 mole. So what is the molar mass of thing? Molar mass, it's given at the top, 283.9. So multiplied by 283.9 gram per mole. Now you got it. For 1 mole of reaction, what is the thing? In the balanced chemical reaction, only 1 mole of P4O10 is there. So this will be the kilojoule per mole reaction. Okay. What I got is negative 450 kilojoule. Okay, kilojoule per mole reaction is the unit. That's all that part. Then next question. Okay. I think it's based on Hess's law. So they were given a reaction. Okay, see the equations. A set of reaction is given, equation 3 and equation 4. And see the equation 5. For this reaction, what is the delta H? The corresponding delta H is what? Okay, same thing, Hess's law. How do you apply? You need to bring this reaction from the set of reaction. Okay, so we need 1 over 4 P4. So let's see in the top, is there any P4 containing? Yes, equation 3 contain P4. So equation 3 multiplied by 1 over 4. Okay, so P4, like 1 over 4 P4, 6 over 4 Cl2, which means, and 4 over 4 means 1 PCl3. And this one I can write 3 over 2. Isn't it? Okay. Then what else I need? I need to bring 5 over 2 Cl2. See, Cl2, what's the problem? Both equation contain Cl2, so I'm just skipping. If both equation contain same species, the correct manipulation we can't do. So just skip the Cl2 this time. And then PCl5. You need PCl5. So which equation contain PCl5? Yes, the second equation, like equation 4. So we need PCl5 as a product, and just one PCl5 is needed. So equation 4 you can take as such. So just nothing, multiplied 1 by 1. So PCl3 plus Cl2 gives PCl5. Okay. Oh, we forgot to the delta H value. See, we are multiplied equation 3 by 1 by 4. Multiply by 1 by 4. So here also minus 1148 divided by 4. And here we didn't do anything. So minus 88. That is the thing. So the total reaction, you will get the same equation what we need. And the sum of this reaction. Sum of this reaction lead the required equation. So sum of this delta H value also give the resultant delta H. Okay, the required. So what is that one? I got minus 375 kilojoule per mole reaction. Okay, that will be the answer for the question E. Right. Then the 5 kilojoule per mole reaction. Okay, that will be the answer for the question E. Right. Then they were given a particle diagram representing the thing. Okay. So the same equation, equation 4. So what is the equation for? PCl3 plus Cl2 I can write there. PCl3 plus Cl2 gives PCl5 is the reaction. So yes. What is the KSP? Sorry, not KSP. What is the KP? Okay, KP may be the question. Yes. Oh, they were already given the equation. Right. So for the F part, equation 4, they were already given, and once again given here, and delta H2, see H2 is also given. Right. If each particle on the diagram represents the partial pressure of 1 atmosphere, what is the value of Kp? So Kp for this reaction, first you can explain, express the expression of Kp, right? Product concentration. Here it's not concentration, partial pressure. Okay, Kp means in terms of pressure. So P of PCl5 and raised to 1 divided by P of PCl3, like pressure of product raised to their stoichiometric coefficient over pressure of reactant raised to their stoichiometric coefficient. So here times pressure of Cl2, partial pressure of Cl2. This is the equation. And then they were telling each partial pressure, number you can consider 1 atmosphere. So see, how many PCl5s are there? 1, 2, 3, 4s are there, right? 4 PCl5 is there, so you can plug 4 here, and PCl3 is 1 2, only 1 2, and the other one is 2 4 6, 2 and 6. Okay, so that's all about the Kp. So what's answer that I got is 0.333. Okay, right. Then, then the second part, does the Kp value increase, decrease, or remain the same when temperature is increased? See, when temperature is increased, definitely equilibrium constant value also change. For endothermic reaction, how the change? For endothermic reaction, if temperature increases, it's direct proportional. Temperature increases, Kp value or K equilibrium value increases. If temperature exothermic reaction, for exothermic reaction, temperature increases, its opposite, inverse reaction, inverse relationship, sorry. Kp decreases. So here they were given it is a exothermic reaction because of the negative 88. So Kp will be decrease while you increase the temperature. Okay, so that is the answer. That's wrap on question number 3. Hope that helped clear things up. If you're finding this FRQ breakdown useful, give this video a thumbs up and make sure you're subscribed to Anu's Chem Corner for more. Let me know in the comments any topic you are struggling with. See you in another video, and as always, keep those reaction balanced and view confidence high. Bye.